Hey, Mr. J, coming at you. I got a video for you on adding fractions. Okay, so we're just going to look at fractions here. We're not going to look at decimals or ratios, percentages, any of that stuff. So just straight up fractions. Okay, so let's make a question here. Let's go with where's my text here? So let's go with what is? Oh my goodness. What is, and let's do 1/2 plus, like, I don't know, 2/5. Okay. So obviously, this is videos for grade 6, grade 7. We're looking at some fractions here with unlike denominators, or their denominators are different. Okay. If you don't remember about denominators and numerators and proper and improper and mixed and all that stuff, go watch the last video where I talked about that thing and modeling and ordering. That's all in the last video. This one is straight up addition, and then the next video is going to be subtraction, and then on to the other two operations. Okay, so there's my question. I guess you should have a question mark. And wow, that was not really as big as I was hoping it would be. Anyways, whatever, there it is. Okay, so obviously the problem is that we have unlike denominators. So if it was 1/2 plus 2/2, we could just say it's 3/2, or 1.5. It would be very simple, and that's the whole point of using like denominators. Okay, is that we're trying to find a denominator that's the same, and we just add up the numbers. It becomes very simple. Okay, now how does that work? Why does it work? What's the model? That's what we're going to talk about right now. I'm going to use these tools because they're a little quicker. Okay, so here we go. So the problem is that if we had a 1/2 here, I'm just going to do a fraction box here, cut it into two parts. Because remember, the numerator is saying I have one part, the denominator is saying there are two parts in a whole, right? So that's what my 1/2 would look like. Now my 2/5, well, this is going to be very difficult for my artistic inabilities, but I would split this. Oh my god, one. This might not work, y'all. Oh, pretty, not bad. One more. Whew. Okay, not the best I've ever done, but certainly not the worst either. So 2/5 would look like these top two shaded in. Okay? So even with the model, I can't really see how those two are going to mesh together. It's not obvious, right? It's not clear. So the solution is I'm going to build the boxes instead out of a combination of the two denominators. So since we have halves and fifths, the most obvious sort of common denominator is tenths. Okay? Easiest way is you just look at the denominators and you say, what is the one denominator times the other denominator? In this case, it's 5 times 2, which is 10. Okay? There's nothing wrong with using that. Sometimes there's like a lower one, and some teachers are going to be obsessed with simplifying and using the smallest one possible. Find the lowest common denominator. I don't care. I don't understand. I've never had a good answer as to why that is the case, other than that's the way we do it. That's the way you do it. What's wrong with tenths? Nothing. What's wrong with whatever? If you want to use hundredths, use hundredths. I don't see a problem with using any common denominator. So the easiest one to find is you just take one denominator, multiply by the other denominator, and in this case, I'm going to use tenths. What's wrong with that? Nothing. Okay, so that's what we're going to use. In this case, it just happens to also be the lowest common denominator, but sometimes it's not, and some teachers get all up in arms about that. I don't get it. Maybe somebody will comment on this video and explain why. I challenge you. Okay, so what I'm going to do here is I'm going to, instead now of using halves and fifths, I'm going to put them together. And I'm going to make my box have 10 parts, okay? Because it's going to still have halves going vertically, and it's going to have horizontal lines making my fifths, okay? But it's all going to be one box. So now I have a couple choices here. Let's do it the simple way. Since I've already drawn my two boxes, I'm going to switch colors here just to make it stand out. I'll go to blue or purple, whatever that is. And I can split this in half very simply by just drawing the half line the same spot it was in the other box. Okay? And so now instead of it being 2 out of 5, it's now 1, 2, 3, 4 out of 10. Okay? And those are, like in the last video, that's equivalent fraction. Okay? With my half, I'm going to split that into fifths the other way, which altogether will make the 10 relatively equally sized boxes. It's pretty good for me, y'all. Okay, so now again, instead of it being 1 out of 2 or half, now it's out of 10, so that's tenths. And how many are there? Instead of there being just 1 out of the 2, now there's 5 filled out of the potential 10. Okay, and then it becomes very simple because I'm just going to add 5/10 plus 4/10, and that's going to give me my 9/10. Okay, so that is like a really good model. That's called an area model because we're comparing how much space we fill up. That's what area is. Okay, so that's an area model. It's my favorite model. There are other models, but I'm not even going to bother with them because this one is so good. It's relatively easy. You don't have to have perfect art skills. Yay me! And I think it's pretty clear. You could write numbers instead of doing the shading. You could use two colors. You could use a highlighter. Just gives a lot of options, and for me, it's very clean. Okay, and you can make the boxes as big as you want. They don't have to be perfectly rectangular, or sorry, they don't have to be perfectly square. They could just be a weird, sketchy rectangle. If you're like me and you draw the lines bad, you could just add a second, like a sixth line or whatever if you need to, just extend it. So it gives you a lot of freedom. Okay, now the other sort of option, if you kind of feel like you don't need a model or you're dealing with really big numbers, well, let's do another one. So instead of doing these lower numbers, like what if it was 7/12 plus 5/8? Whoa. Okay, I don't want to draw that. Like I like models. You know me, I'm crazy. I'm all about the models. I'm all about the why. That's the way I live my life, right? Um, but I don't want to draw that. Like you saw how hard of a time I had drawing fifths. Like 12ths and eighths, no thank you. Okay. Could I do it? Sure. If it was a test, would I do it? Maybe, because I want to get as many marks as possible, but I'm not going to do it right now. Okay. So this is where we're going to take the model and just sort of apply it with numbers. Okay. So in this case, again, I see that I've got 12 and 8. Okay. Now what is 12 times 8? Well, 8 times 10 is 80, and another 2 8s is 16. So it's going to be 96. Okay. Is there a lower number I could have used? Yeah. Okay. I see that I could have used 24, okay, because 8 times 3 is 24, and 12 times 2 is 24. So I could have used 24, and there's 48. Like there's other ones I could have used. Is that better? Is using 24 better than 96? I don't know. I don't see why. What's wrong with 96? I mean, it's close to 100. It's almost going to give me a percentage answer, which is kind of cool. What's wrong with 96? I'm going to use 96, okay? So I just add my fraction bar there, and then I'm going to say, okay, well, how did I get from 8 to 96? And that was times 12. And I do like to write this. I don't like to just keep in my head, because what I find in the test, or when it matters, I should say, whatever, an assignment, whatever, something that's, for marks and really matters, okay, here it's times 8. What happens is that kids know, like, okay, it's 12 times 8, so I got to do that, and then I'm going to do 8 times 8, or whatever. They just keep that 8 in their mind. So I do find writing that what I'm multiplying by is very helpful, okay? So now I've got 7 times 8, so, oh man, that's 7 times 8, 14, 28, 50, okay, so 56. And again, use a calculator if you're not sure, okay? So that was 7 times 8, because whatever I do, numerator times 8, now I'm doing denominator times 8, now I'm doing the numerator times 8, okay? And same here, 8 times 12 gave me 96. I'm going to do 5 times 12, which is 60, to give me the other numerator, okay? And that, again, use a calculator if you're not sure, okay? Now I can just add them nice and clean. And I got 60 and 56. That's 116, 116, okay? And over 96. And for me, in my class, that's good. That's my answer, okay? 116 over 96 is a perfectly good answer. That's the answer. What's wrong with that? Okay. Could you simplify? Sure. Could you turn it into a mixed number? Sure. I don't need that in my life. Okay. If you want to practice that for future teachers, go nuts. 116 and 96, that's a fraction I understand. 96 would be the whole. I've got more than a whole. I understand that's a whole. I don't need to do any additional work on that. If you want to, go nuts. But for me, that's a perfectly good answer. Okay. So that's adding fractions. And I would take either of these as a model. I know only one is a visual model. The other one is more numeric, which is okay for me too. If you show your steps, I'm happy. I would give full marks for either of these answers. Hey, I'd even be happier to see both. But yeah, that would be great. Okay, just make sure you show your steps, because if you mess up and it's wrong, then it's 0. If you show your steps, it's part marks for sure. I might even give full marks. If you just make a little calculation error or something like that, I'll probably still give you full marks because this is a test or an assignment on fractions. Okay, so there you go, adding fractions. Peace out.